Hello all, welcome to this second lecture video of computer network, and today we are going to see one of the most important, actually the most important topic of computer network, that is OSI model. OSI means open system interconnection, and in this lecture video we are going to see all the features of OSI model. So in last video only we were discussing that computer network means a collection of devices which will be connected by the transmission media, and those devices will be sending information to each other. Okay. Now for communicating the information, only having the device and the transmission media is not sufficient. Okay, they need to be connected, that is one requirement, but only connection, as I said, is not sufficient. So what else they need is they will be requiring software to be installed in each and every device. Okay, now that software is going to implement protocol. Protocol is nothing but a set of rules, okay, which all the devices that is connected in a network will have to follow. Okay, and as per the protocol, as per the set of rules, the message from one device will be communicated to the other device, and hence they will be able to understand the message, they will be able to interpret the message. Okay, as well as the network will be able to carry the message and deliver to the correct destination. Okay, now how this will be implemented is the network follows this layered architecture. Okay, so in this layered architecture, the message, once it is generated, will be going through set of layers before actually delivering that to the network. Okay, network here is the transmission media which is going to carry the message and deliver to the destination. Okay, so consider a sender computer wherein a user is writing a message, and that message needs to be forwarded to some another node which is connected in the network. So node here means a computer or a device. Now the message will go through a set of layers. Okay, here layer is nothing but the software layer. Okay, so there will be various software layers in that device, and the message will be processed by each software layer, and finally by the lowermost software layer the message will be forwarded to the network. Okay, that is, the message will be put on in the transmission media which will be carrying the message, and it will be delivering that message to the destination computer. Similarly, in the destination computer also, once the destination receives the message, it will be taking the message, and again there will be software layers. Okay, there will be various layers of software which is going to process the message, and finally the message will be given to the user. Okay, in simple, the one simple example is the message that the sender will be writing. It will be in form of English or in numbers. Okay, now that English, the message which is in form of English or in number, cannot be understood by the computer and the network. Okay, and one work of the software layer is to convert that message, okay, which is in alphanumerical form, to sequence of bits. Then the computer will be able to process. A computer can understand only zeros and ones. Okay, and once computer understand that message, the computer will have to convert that message into the form of signal, because transmission media can carry only signals. Okay, they cannot carry bits, zeros and ones, or neither they can carry a message which is in form of alphanumeric values. Okay, so which means that one use of these layers will be, first of all, to convert that message which is in form of alphanumerical characters into the form of bits. Okay, process that bits. There will be so many functions, so many reasons to process the bits, and then finally convert that message which is in form of sequence of bits into the form of signal. Okay, now transmission media will be carrying that signal, and it will be giving it to the destination computer. Now signal cannot be understood by user, isn't it? So first of all, that signal needs to be converted into the sequence of bits so that computer can understand, and once computer understands, then the computer will have to convert it into the form of alphanumerical characters. So that means in the destination side, the signal message which is in form of signal will be converted into the sequence of bits and then to the form of alphanumerical characters. So this is one use of the software layer. Okay, another use of software layer, as I had discussed in the last video, that security is one very important um, feature in the network which every network has to deal with. Okay, for providing security, the message will be converted into some form. Okay, some changes will be done in the original message, and that will be done by the software layer before actually putting that message in the network, okay, or in the transmission media. So this way there are various functions which the software layers that has to be installed in the sender computer, receiver computer, and all the intermediate device, okay, will be performing. So as I said, it is the layered architecture that will be followed in the computer network, because in the practical life also, how two people can communicate, okay, who are far from each other, if they want to communicate by post, okay, by sending a letter, then how they communicate. This is an example. Like the person sender will be writing a message, and the sender will have to put that message or the letter in a letter. Or in the envelope, and then envelope will be given to the postman will carry that envelope to the post office. Now from one post office to the another post office, the envelope will be carried by some media, okay, some carrier, and that carrier will be giving that envelope to the destination post office, which will be again carrying that message and giving it to the actual receiver. Okay, so these are the set of functions that needs to be performed for two people to communicate. So similarly in the computer network also, for two devices to communicate, both the device, okay, in the sending side, before actually sending the message, it will be performing some set of operations. Similarly in the receiving side also, once it receives a message from the network, before actually giving that message to the receiver, it will also be performing some operations. Okay. Now, how this software layers needs to be implemented, what are the functions, okay, it can have, and in what order those functions needs to be executed, is defined by this very famous model called OSI model, okay, which has been standardized by ISO in 1947. So ISO has standardized this OSI, and the full form of OSI is Open System Interconnection, and it is a model. Okay, remember that this OSI is not the software, okay, or it is not the protocol. Okay, so the software that will be present in all the devices, they are going to implement the protocols, various protocols, okay, and each protocol is going to define the set of rules. This OSI is not actually the protocol, it is just a model, okay, which has the definition regarding how many layers a computer can have. In each layer, what are the functions that can be implemented, okay, in which order those functions needs to be implemented, or the program needs to be written in which order it is to be executed, and so on. Okay, so OSI, you can imagine it is like a book, okay, which has given all the descriptions about the software layer which can have the different types of functions, which can implement the different types of functions. Okay. So, as I said, ISO is the organization which has recognized or which has standardized OSI, and OSI is a model which defines what are the different protocols that can be implemented in the software layer in each and every devices that is connected in the network. Okay, and so this OSI reference model is made up of 7 layers. Okay, so the software layers, if it is following OSI reference model exactly, then it can have maximum up to 7 layers, and each layer will be executing set of network related functions. Okay, now having this kind of structure is actually breaking all the functions into many groups, which will be easy to manage. Okay, and each software layer will be providing the services to its upper layer. So every upper layer is going to use the services or the functions that the lower layer will be providing to it. So as I said, in total it is going to have 7 layers, okay, and those 7 layers are physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and the application layer. Okay, the lower so out of 7 layer, the lowermost 3 layers, that is layer 1, layer 2, and layer 3, which includes physical, data link, and the network layer. These 3 layers are called user support layer. Sorry, these 3 layers are called network support layer. Okay, so you have physical layer, data link layer, and the network layer that is going to have the functions related to network. And after that you have the transport layer. Then on top of transport layer you have the session layer, presentation, and application layer, which is going to implement the functions related to users. So the top 3 layer is called user support layer, the lower 3 layer is called network support layer, and in between you have a transport layer, which is going to combine the functionality of this network support layer and the user support layer. Okay, so how many layers this OSM model has? OSM model has 7 layers, 7 software layers, and that is physical, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Physical, data link, and network layer, they implement the functions related to the network. Transport layer is used to connect these 3 layers with the upper 3 layers. And session layer, presentation layer, and application layer, they are responsible for implementing the functions related to the user or the application. Okay, that is communicating or that is sending messages to the network. So now let's see how these 7 layers will be implemented in each device, okay, in the different computers that will be connected in the network. So you can see here there are two devices, two computer A and computer B, and in both the computer, all 7 layers, okay, that was defined by OSM model has been implemented, and in between there are some devices. Okay, these are networking or internetworking device that will be used to connect the different computers, or that can be used to connect the different networks. Okay, so in these two networking device, also some of the layers of OSM model has been implemented, and that is physical, data link, and the network layer. Okay, so in the sender computer, all 7 layers are physical, data link, network, transport, session, presentation, and application. Similarly, in the receiver computer also there are all 7 layers, and in the intermediate devices there are 3 layers that has been installed as per the requirement, because they do not need remaining 4 layers. Okay. Now these are the software layer, and as I said, each layer is going to implement some set of protocols, and each protocol is nothing but a function or a set of rules. Okay, and the sender first of all is going to generate a message. That message first of all will be given to the application layer, which is going to do some processing in the message, and which will be forwarded to the next layer, presentation. From presentation the message will go to session, then it will go to transport, then it will go to network, then data link, then physical, and finally the message will be put on the network or the transmission media, and the network is going to carry the message, and in between if there is some intermediate device, then again the message will go up. That means first of all the message will be taken by physical layer, it will be given to the data link layer, then network layer, and some processing will be done, and again the message will go back to data link layer, physical layer, then again the network, again network will carry that message. Again if there is another intermediate device, then it will go to physical, data link, network, and again back to data link, physical, and again to the network, and finally it will be given to the receiver device. Now in the receiver device also, first of all the message will be received by physical layer, then it will do some processing in the message, then it will be given to the data link layer, then network layer, transport layer, session layer, presentation layer, application layer, and finally the message will be given or shown to the user, okay, of the receiving device. So this is how the message will be communicated to the network, and between each layer there is an interface. Okay, so the interface is going to define what are the services or the information that the lower layer must provide to the upper layer. That means this interface between application and the presentation layer is going to define what are the functions that the presentation layer is going to provide to the application layer. So similarly, you can see here between every two layer there is an interface, and which is going to define the services that lower layer, just lower to that interface, must provide to the layer which is just above that interface. And the whatever function was executed, okay, in each layer, just the reverse function will be executed by the corresponding layer in the receiving computer. For example, whatever was done by the application layer in the sender computer, its related function will be executed by the application layer in the receiving computer. Similarly, one of the tasks of physical layer is to convert the bit stream, okay, into the form of signals. Similarly, in the receiving side, the receiver's physical layer is going to take the signal from the network and it is going to convert it into the form of sequence of bits. So this is how the different layers will be related to each other. So that is, application layer is related to the application layer of the receiving device. Presentation layer is related to the functions of presentation layer in the receiving device, and so on. So this processes, okay, in the corresponding process are called peer-to-peer process. Okay, they will be executing peer-to-peer protocol. Now each layer, they are also going to add some information in the actual message. Okay, so that information can be added in the beginning of the message, or it can be added at the end of the message. Okay, now the message, the information that is added in the beginning, that is called header, and some information that is added at the end of the message, that is called trailer. So all the layers will be adding some information, okay, extra information in the header part, whereas this data link layer, it is also going to store the information in the trailer part. Okay, so you can say here that in the beginning the sender device will be creating a message, application layer is going to add header, that is some extra information in the beginning of the message, in the front of the message. Now that as a whole will be will be sent to presentation layer, which is again going to add some extra information in the header. Again, it will go to session layer. So this is how it will be communicated. Now in the receiving side, just the reverse operation will be done. So every layer is going to read or understand or use the information that was added by its corresponding layer in the sending side and remove that header or the trailer part. So that is, let us say the actual message that was generated in the application layer was, let us say, D7. Okay, in this layer 7, this is the actual message. So layer 7, that is the application layer, has added a header, which is the extra information in front of message, and this as a whole will be sent to the lower layer, that is layer 6. Okay, presentation layer. So which is again going to add some extra information in the beginning of the message. Then again, this as a whole is being sent to the lower layer, that is session layer. Again, it is adding some extra information in the header. Again, it is going to fourth layer, that is transport layers, which is adding some extra information, that is a header. Then it is going to network layer, which is adding header again. Then it is going to data link layer, which is adding header as well as trailer. Okay, so data link layer, in the trailer section, it is going to add the information related to error control and all. This thing we are going to see later on. And this message as a whole will be sent to physical layer, which is again going to add header, and then the entire message will be converted into the form of signal, which will be transmitted by the transmission media. Finally, receiver will be receiving that entire message, and in each layer the reverse operation will be done. That is, this was the message, entire message that the receiver has received. The physical layer is going to remove this header, and remaining portion it will give to data link layer. Data link layer is removing this header and the trailer. Okay, they are going to contain the information for that particular layer. So they are going to use the information and remove the header as well as trailer. Again, it will be given to the network layer, use the header and remove it, then it will be given to the transport layer, session layer, presentation layer, and finally the application layer. So application layer is going to remove this particular header, and this was the actual message that was generated by sender, which will be given to the receiver. Okay. This process is called encapsulation in the sending side and decapsulation in the receiving side. Okay, encapsulation means the process of addition of header and trailer, and decapsulation means the process of reading or understanding the header and trailer and removing it. Okay, and then the message will be given to the upper layer. Next, we are going to see the functions of each layer in detail. So as I said, there are 7 layers, and we are going to see in each layer what are the different functions that can be implemented. So the first one is physical layer. So physical layer is the lowermost layer, and the message that the physical layer will be getting, it will be getting from the data link layer. So once it receives the message, the physical layer is going to implement some functions in it, and then finally it will be given to the transmission medium. And whatever was done by the sender's physical layer, the related operations will be executed by the receiver's physical layer. So the main objective of the physical layer is to make sure that whatever it is generating, the network is capable of carrying it. Okay, so it is related to specifying the mechanical and electrical specification of the message. So that means main objective is to convert as per what type of transmission media is connected, to convert the message into that form of signals. Like if the transmission media is twisted pair cable, then the signal has to be electrical signal. Okay, if the transmission media is fiber optic cable, then the signal has to be in form of light. So based on what type of network the computer is connected, the physical layer will have to convert the message in a form which that network can carry. So physical layer is responsible for movement of each individual bit of the message. Okay, now, so this physical layer deals with the physical characteristics of the network, okay, and what type of signals needs to be communicated, okay, what are the different types of port that can be used, what are the different types of transmission media that can be supported by the computer as well as the network, okay, what should be the data rate, what should be the maximum transmission distance, okay, and many other attributes. So these are the things that the physical layer is responsible for managing. So some of the very important functions of physical layer are, the first one is it defines the physical characteristics of interface and the media. Okay, what type of transmission media can be connected, what type of interface or the port that can be used is being decided by the physical layer. Second important function is whatever message it will be receiving from the data link layer, that will be in form of sequence of bits. Okay, sequence of bits computer can understand but network cannot carry. Okay, so that needs to be converted into the form of signal, which will be done by physical layer based on the type of transmission media that is connected in the network. Next function is data rate. Okay, data rate is the speed with which the information will be sent by the sender. Now, data rate, as I had discussed in the previous video, also is very important. Okay. Now, the next function is synchronization of bit. Remember that the sender and the receiver, they have to be synchronized in the clock level. That is, the clock, if it is high, then let us say the device is capable of sending and receiving. So once the bit is sent by the sender, it has to be received by the receiver when its clock is high. Okay, otherwise if it is low, then that particular bit will be missed by the receiver. So sender and the receiver, they will have to be synchronized in the bit level, which will be ensured by the physical layer of both sender and the receiver computer. Next function is to define about the type of line configuration. Line configuration is nothing but the type of connection. Like we had discussed previously, we can connect the two devices using point-to-point method, or we can use the multi-point method. So that will be decided by the physical layer. And it also, there is one more point that is missing, that is the topology, which is again related to line configuration. That is how all the devices can be connected to each other. That will also be defined by the physical layer, and the different transmission mode, okay, whether different devices are communicating in simplex form, half duplex form, or in the full duplex form. So that was physical layer, that is layer 1. The second layer, layer 2, is data link layer. So data link layer will be receiving messages from its upper layer, which is network layer, and after processing, it will be giving that entire message to the lower layer, that is physical layer. Okay. So this is the example for the sending side, and this is for the receiving side. Now, the main function of the data link layer is to make sure that the data can be transmitted from one hop to the next hop. Okay, that is hop to hop. Hop here is nothing but a node. Node is also nothing but a device. Okay, device in a network which is capable of sending or receiving. So the data link layer, its main function is to move the data packet from one hop to its next hop. Okay, and the message in the data link layer is called frame. You need to remember that in each layer every message is given some name. Okay, so that we can identify that we are talking about message in which layer. So in data link layer a message is called frame, and the main purpose of data link layer is hop to hop delivery, okay, or node to node delivery. So we are going to see what exactly this node to node delivery is. Now see this example. Let us say this is the sender computer and this is the receiver computer. Now in between there are some intermediate devices, that is router. This is the symbol to represent a device called router. What is this router? We will see later on. Just understand that this is a device which is used to connect a different network or the different devices. Now let us say the sender computer is sending a message to the receiver computer, and the message will have to go through many intermediate nodes. Okay. Now the sender computer will first of all be assigning the another type of address of the receiver computer, that is called logical address or the IP address, and the message based on whatever IP address is there will be identifying the path, and it will be traveling through that path. Now when the message needs to move through the actual physical link, okay, the message so for example, so here from computer A the message will have to go to device B, then it will have to go to device C, then finally it will be reaching device D. So the communication between each successive device is called node to node delivery, okay, or hop to hop delivery, okay, so or a device to device delivery. So communication between this node A and node B is called one hop to hop delivery. Communication between B and C is called one hop to hop delivery, and between C and D is called one hop to hop delivery. Okay. Now, when a signal needs to be given to a computer, okay, or a device, that device needs to be first of all identified. Okay, so that can be done by using the physical address of a device. So every device will have a physical address which will be imprinted in a card called NIC card. NIC means network interface card. Okay, so every device that is there in the network, they are going to have an IC card wherein a address or a ID will be imprinted that is going to identify that device by the network. Okay, so that is, for example, here by this network, once it gets the message from computer A, okay, it will be identifying computer B or the device B by using the physical address of device B. Okay, so for sending a message from A to D, it needs to go to B, and from B it needs to go to C, then from C it needs to go to D. So every node, that is B, C and D, they can be identified, okay, by their previous device, okay, by their predecessor, by using the physical address. So in the sender computer, first of all, the message to identify that destination, it needs to insert the IP address of the actual destination device. Now, because now with that, it also has to go through various intermediate device. So it also, the message also needs to have the physical address of its immediate next device, that is device B. So the message is going to contain the physical address of device B. Because of that physical address, the network will be able to identify device B, and the signal will be given to the device B. Now, from device B, the signal needs to be given to device C. So here the physical address of the device C needs to be inserted in the message so that this network can identify that it is this device and signal can be given to this device. Similarly, from here, the message needs to contain the physical address of this device, and based on that, the network will be identifying it and it will be giving the message to this device. That is, for example, uh, let us say we have device A which needs to send a message to device D, but it has to go through two intermediate device B and C. Okay. Now all the device that is connected in the network, they are going to have NIC card, network interface card, wherein address will be imprinted, that is called physical address. Now in between this device, they are going to there is a transmission media, or you can say, so there is a network here, some form of transmission media is there between every two device. Okay. Now once this network gets a message, let us say this is a message, once this network gets a message, okay, it will be able to read and understand only the physical address, because the address will be in such a form that the network can understand, and based on the physical address it will identify which another node the message needs to be given. Okay, so when A will be generating that message, it will have to insert the physical address of B, okay, in the message. Now message will be given to the network. Now since network can understand the physical address, based on that, network will be giving that message to the node B. Now B, whatever physical address was there in A's, when A had sent the message, it will be removing that physical address and it will be inserting the physical address of its next node, that is C. So in this message previously there was B, now that will be removed and the physical address of C will be inserted, and again the message will be sent to the network, wherein the network will be delivering that message to C. Now similarly, C is getting a message which is having the physical address of C itself. Now that message needs to be given to D. So C will be replacing that address by the physical address of D. Okay, and the message will be given to the network, and from where the message will ultimately be delivered to the destination computer. Okay, so this communication between every successive node, okay, is called hop to hop delivery, and the function that will be implemented for hop to hop delivery is by using the data link layer. So some of the example of data link layer functions or the protocol or the software layer are Ethernet, frame relay, FDDI. So these are the various responsibility of the data link layer. We are going to discuss each one of them. The first function is framing. That is, whatever data link layer receives from the network layer, first of all, it is going to divide that entire data set into small segment. Okay, that is called frame. Okay, each division, okay, or each chunk is called frame in data link layer. Second function of data link layer is physical addressing that I was discussing just now, that for sending a message, it needs to insert the physical layer of the next node, okay, to whom the message needs to be given. And that physical address is nothing but an address which will be imprinted in NIC card. That address is also called MAC address, okay, which is of 48 bits. The next function is flow control. Flow control is related to the speed with which the sender is supposed to send the message. Okay. See, suppose we were discussing in the last video also that suppose the speed with which receiver is processing the data, okay, is very less in comparison to speed with which sender is transmitting the data, then what will happen is the receiver will not be able to accept all the bits that it is receiving from the network. Okay, now if the receiver does not receive it, then those bits will be lost in the network itself. So this is called overwhelming problem. So the speed with which the sender is transmitting the data should not be overwhelming the receiver. So that is a flow control, okay, which means that in which data rate or the speed that the sender is transmitting, it has to make sure that receiver is capable of receiving in that speed, okay, and process in that speed. The next function of data link layer is error control. So error control in data link layer means to find out using this mechanism the receiver will be able to figure out that whatever frame it is receiving whether it was damaged during transmission or not, okay, because between sender and the receiver there is a network from where the signal is getting propagated, and in the network if there is any noise interference devices, okay, any device which is generating electromagnetic signal, then that is going to distort the message. That means that is going to change the bits of the message. It may change bit from 0 to 1 or from 1 to 0, which is going to give some other information to the receiver, isn't it? So the data link layer is going to add some information. Actually, this will be done in the trailer section. In the trailer of the packet, data link layer will be adding some extra information, and using that extra information by the receiver will be able to identify whether that message was distorted during transmission or not. Okay, this error control is actually related to the noise interference which may damage the frame, okay, which receiver is receiving. So receiver is going to use this error control mechanism to identify the damaged frame, and if the frame is damaged, either it can correct the frame, okay, if it has the mechanism of error correction, otherwise it will be informing this to sender, and the sender is going to retransmit that frame. Next function of the data link layer is access control, and this is mainly used whenever the network is being shared by multiple devices. Okay, so channel or the transmission media, if it is simultaneously being used by more than one device, and if they transmit their data simultaneously, then what will happen is their data in the transmission media may collide with each other and they will be damaged. Okay, so in that case what will happen, what can be done is data link layer can implement this access control mechanism wherein every device will be given information about when they can transmit, okay, so that their messages do not collide in the network, because if they collide that will be lost. So next layer is network layer, which is very important, and this layer receives the message from transport layer, and after processing it forwards the message to its lower layer, that is data link layer. And the main function of the network layer is source to destination delivery. Okay, so this we are going to see with an example. Like here, let's say that device A needs to send a message to device D. Okay, first of all, in this entire network, okay, so this is a very big network. In the entire network, this destination D, okay, that is the device D, needs to be uniquely identified. Okay, so based on that, the message will be communicated, and the path, okay, to reach that destination device will be identified. We had discussed about one type of address in the previous layer, that is data link layer, which is physical address. Okay, so remember that physical address is not unique globally. Okay, that will be unique within a network only. Like for example, between these two devices there is a network. Okay, there can be so many other devices that can be connected, and within this network this physical address will be unique. Similarly, within this network the physical address of B and C, they will be unique. Okay, similarly within this network physical address of C and D will be unique, but physical address cannot be unique globally, because that is an address which depends on the manufacturer, and the manufacturer will be imprinting that address in the physical card or the NIC card. So it is not unique. Now, to identify every device uniquely in the entire network or the internetwork, then we need to have one more type of address, okay, that needs to be managed globally, and this is called logical address or the IP address. Now, using the IP address, every device can be identified uniquely. Okay, but using logical address, the message cannot be transmitted by the network. Okay, that is, suppose if A gives the logical address of B, network will not be able to deliver that message to device B. It needs to have the physical address so that signal can be given to B, because network can understand only this physical address, okay, to deliver a message. But the network also needs to identify, okay, identify the receiver device. That is, in this example receiver is B, so network needs to identify that what are the intermediate nodes, okay, that to which the message needs to be forwarded so that it can reach D. So that is, here you can see the intermediate devices has to be B and C, then only message will reach D. If the intermediate device followed is B and E, then message will not reach D, isn't it? So identifying all the intermediate node, this process is called routing, okay, or finding the path. The process of finding a path is called routing. Now, to perform the routing, okay, to find the path, you need to be able to identify the destination node uniquely. And as I said, this will be done by using another type of address, logical address called IP address, okay, or the logical address. Now, using the logical address, okay, the network will be identifying all the intermediate node, and using the physical address, the message will be given to every intermediate nodes. Okay, the message will be inserted to every intermediate node. They are going to process it again. They are going to give the physical address of next intermediate node, and finally, that way the message will reach the destination. Like for example, so in this case, A needs to send to D. Okay, so if this is the message, A will also be inserting the logical address of D. Okay, let us say this field is to insert the logical address, and using this logical address, this network will be able to identify that the message needs to be forwarded to B, then only it can reach D. Okay, using some algorithm, it will be able to identify the path. Now, that information, that is the logical address, which is D, will be present in the message, and based on that, again the network between B and C will be able to identify that the next node has to be C, and B will be changing the physical address to the physical address of C, and the data will be given to C. Similarly, C will also be able to identify that it is the D, and the physical address of D will be used to give the data to this D. Okay, so what is happening here? In the message, the physical address is getting changed between every successive node, but the logical address will remain same. For A also, the actual destination is D. For B also, the actual destination is D. For in C also, actual destination is D. So what we are doing using the logical address of D is, we are using the logical address of D to find the path. Okay, to find every intermediate node, and using the physical address, we are actually giving that message to that particular to the next node. So like IP, IPX, AppleTalk, these are the example of network layer protocols. And you can see here that the main objective of network layer is source to destination delivery. Okay, once a message is generated by sender, to make sure that the message finally reaches the destination. Okay, for that, because the network can be very huge and there can be so many paths, okay, in between sender and the receiver, which path need to be followed so that receiver can get the message will be done by using the functions of the network layer. So there are basically two functions of the network layer, which is logical addressing and routing. Logical addressing, as I already said, is a job of assigning IP address, okay, of the destination, using which the network will be identifying that where exactly the destination is present and how to reach that destination node. And second function is routing. So routing is the process of finding the path. Okay, so every device is going to execute an algorithm called routing algorithm, and this routing algorithm is going to find how to find the destination and how to reach the destination. Okay, so the next layer is transport layer, which is layer 4. Okay, and network layer, as we had seen, in the network layer, its main responsibility is to carry the message from one node to another node, okay, to the source to the destination, or host to host delivery is the function of network layer. But remember that the message giving it to the destination computer is not sufficient. Okay, the message needs to be ultimately given to the actual process which is running in the destination computer. That is the end-to-end communication. Whenever we are talking about, it is not between the sender computer and the receiver computer. Okay, it is in between the process, okay, one process of the sender computer to one process of the receiving computer. Okay, like for example, if I'm sending email, okay, via Yahoo Mail, and my Yahoo Mail is a process which is generating my message, and I have a sender computer which is going to forward my message. And if the network delivers that message only to the receiver computer, that is not sufficient. Okay, from the receiver computer, the message has to be delivered to the correct process. That is, it has to go to only Yahoo Mail. Okay, that is running in the receiving process. So process is nothing but a program which is in running form. Okay, so one computer can have many programs, and more than one program may be generating message to be communicated via the network. Okay, now to which process the message is destined to, the message has to be delivered to that receiving process only. Okay, so that is, you can see here in this diagram that there are three processes which is currently running in the sender computer, and again there are three processes which are running in the destination computer. Okay, now one of the process is generating a message in that computer. The computer is sending that message to the network, and finally the receiver computer is receiving the message. Once the message is received by the receiving computer, since there are three processes, first of all the receiving computer will have to be able to identify which is the correct process, okay, to which the message needs to be delivered, and then receiving computer should be forwarding that message to that correct process. So this is the function of transport layer, that is, from process to process delivery, the responsibility will be taken care by the transport layer functions. So as I said, transport layer is responsible for delivering a message from one process to another process. Okay, so how this will be done is by using the process ID. Okay, once message reaches the destination, to which process ID the message needs to be forwarded, that process number or the process ID will be inserted by the transport layer. Okay. So as I said, the transport layer will be getting the message from upper layer, that is session layer, and it will be giving that message to the lower layer, that is network layer. And the different functions that the transport layer needs to execute is, one first important function is it needs to insert the address or the ID of receiver process. Okay, and if the receiver process may want to communicate back with the sender process, so it will also need to add the ID of sender process. So insertion of process ID, okay, or process number is one important function of transport layer. Other than this, transport layer, whatever it will be receiving from the session layer, the upper layer can be, that message can be very huge, okay, which may be difficult for the transport layer and the network layer to process. So that can be divided into many segments, okay, or small chunk. So each segment will be considered separately, and a different packet will be formed for each segment. And in the transport layer, the message, okay, each packet is called segment here. So as we were discussing that in case of in data link layer it is called frame. I forgot to discuss that in network layer each message is called packet, okay. The same thing in the transport layer, it is called segment. That if we are using TCP protocol, but if we use another protocol that is UDP in transport layer, then it is also called as datagram, okay. So in transport layer a message can be called segment or the datagram. Now that message will be forwarded to the network layer. Similarly, in the receiving side, whatever segments or the datagrams it is receiving, it is going to process it and giving it to the session layer and so on. So this shows the different functions of transport layer. One of the important function is service point addressing, that is to assign the process number or process ID. Okay, so here the address that is used to identify a process is called port number. Okay, remember this term. We are going to use it very frequently. Port number is nothing but a number that is used to identify a process. Actually, every process, once it gets generated in a computer, will be assigned or will be given with some block of memory. Okay, so that block of memory which will be dedicated for the process, for each process, that is called port. Okay, and every port or the block of memory will have a unique number. Okay, that number is called port number. So once the destination receives the message, it will be storing that. It cannot directly give to a running process because a process may be doing some task. Okay, it cannot interrupt directly in between and give the message. It cannot happen all the time. So what computer does is, computer will be identifying that process by using the port number, and it will be storing that message in that port. Okay, port is nothing but the buffer or the block of memory that is given to that process. Now for that each and every process, they are going to have separate port, and to whichever process the message is destined to, okay, the in the port of that process the message will be stored. Okay, so port number will be used to identify a process, and this port number, the assignment process of the port number will be done by the transport layer. Next function of transport layer is segmentation and re-assembly. Segmentation means to divide the entire message into small segment, and every segment will be given a number, that is a segment number. This will be used by the receiver to identify whether any segment was lost in the network or not, or if it is receiving some segment more than once. Okay, duplicate segment that can happen because of error in the network. And using the segment number, receiver will be able to arrange all the segment, okay, and forward it to the upper layer, that is session layer. Next function is of transport layer, very important, is to implement connection service. Okay, whether we want connection oriented service or we want connection less service. Okay, that is the responsibility of transport layer. Connection oriented service means between sender and the receiver, a connection will be established. Okay, a path will be reserved, and from that connection only, all the data communication will take place. That is a connection oriented, and that is mainly used if we want reliable communication. And if some packet is dropped, then there will be acknowledgement mechanism by which the receiver will be informing to sender that the packet or the segment was lost and so on. Connectionless does not create connection between sender and the receiver, and every packet will be considered as an independent packet, and every packet or the segment can follow any path to reach the destination. Okay, that is connectionless. So what type of the connection service we want, that can be decided by the transport layer. Next function is flow control. As we had discussed about the flow control in data link layer. Okay, that flow control in data link layer was in between computer. Okay, now this flow control is in between process. Now the speed of the process can also be different. The speed with which sender process is generating message, with that speed receiver may not be able to receive it. Okay, so sender will have to make sure that the receiver can process it. It should not overwhelm the receiver. So sender will have to slow down. That is the flow control in the transport layer. Okay, that will happen in between processes. Next is error control. Error control here is again in between the processes. That is, once the message has reached the destination computer, that is destination, from here to here, okay, to between the destination to the process, whatever error is there can be identified by using the functions of the transport layer, and usually the error will be corrected by the transport layer by using the function of retransmission. Okay, that is, it will be informing the sender and sender will be retransmitting the correct message. So next layer is session layer. So this session layer may not be required or needed in all type of application, but if an application wants to have a dialogue or a chat conversation, that is, whatever sender is sending, instantly the receiver should be able to read and receive it. So for that, between sender and the receiver, a dialogue needs to be created, okay, or a path needs to be resolved that will be dedicated for that sender and the receiver. So that will be done by using the session layer. So session layer, here you can see it will be receiving the message from the presentation layer and it will be forwarding the message to the transport layer. So as I said, session layer, its main function is to create the dialogue, okay, or to create the chat session, and another function is synchronization. So synchronization means, suppose there are a large number of files if the sender is sending, then like after sending lot of file, if the receiver found out that there was some error in some file, then what usually happens is receiver will be informing this to sender and sender will be retransmitting all the files. Okay, but instead of that, we can use a function of checkpointing. That is, let us say after every 100 file, the receiver will be checking for any kind of error, and if there is no error, it will be performing checkpointing after 100 files. So once there is a checkpoint, it means all the files prior to that has been already checked. Okay, let us say sender is sending 500 files. Okay, so after sending 500, let us say 20 file, receiver found out that there is error in the received file. In that case, once it informs about this to sender, sender will not be sending all 500 files. Okay, it will be sending only the file starting from 500 to 523 and so on. Okay. Next layer is presentation layer, and this layer receives the data from the application layer and it will be giving that data to the session layer. Up till session layer, okay, from data link layer to the session layer, the format of the data was bits in form of zeros and ones. Okay, because it was in form of zeros and one, each layer were able to understand that data and they were able to process it. Okay, now the application layer, whatever data it will be generating, that will be in form of alphanumeric values, like email. I am writing email that has images, that has alphabets, that has numbers. Okay, but that cannot be processed by computer because it is not in form of zeros and ones. So main function of presentation layer is to convert this message, okay, which is in alphanumerical format, or it can be image or it can be video and so on, into the form of sequence of bits. Okay, so that will be done by the presentation layer. With that, it also has the other function, that is encryption, decryption, and the compression. So in total, there are three functions of presentation layer. The first one is translation. Translation is to convert the sequence of bit from alphanumerical format to the bit stream. Encryption decryption is mainly used to provide the security feature. Okay, that is, if I want security to my message, then my message needs to be converted into some another format. Okay, that will be done by using encryption algorithm. And in the receiving side, the message which is in some other form needs to be converted back to the original form, and that will be done by using decryption algorithm. And the last function of presentation layer, which if we want to, we can use, that is compression. Okay, this is mainly used in multimedia data, like while sending audio or video. So multimedia data usually will have large number of bits, okay, large number of information. So if we want to compress, we can compress. Like for example, if I'm talking and in between there is silent, okay, silent is being represented by bit 0. So if there is very large number of 100 0, okay, instead of writing 100 0, okay, let me set 100 100 and 10. Okay, so that we will see about details this later on. So we can reduce the total number of bits in the multimedia data by using the compression function. And the last layer, that is the layer 7, is the application layer. Okay, application layer is the layer which will be visible to the user. Okay, one example of application layer is browser. If you want to use internet, you need to open a browser, or like the Google Chrome, Firefox, Internet Explorer. These are the browser, okay? And this is nothing but the software which will be implemented in the application layer, okay? So application layer, the main function is to provide interface to the user to interact with the network, okay? To send message to the network or to receive message from the network. So the application layer, as I said, is going to get the message from the user, which can be human or the another application program, and that message it is going to process it and it is going to give to the presentation layer. Suppose if I want to send an email, okay, I need to open browser and I need to open one of the email application like Yahoo Mail. There I'll be writing my mail and then I'll be sending. So that interface which Yahoo Mail has provided to me, like there will be compose, okay, to write the email, there will be inbox, outbox, and so on. That is the functions of the application layer, okay? And using those, I'll be writing a message and the message will be given to the next layer, that is presentation layer. Okay, so there are various functions of application layer, some of which are network virtual terminal. Okay, network virtual terminal is like if you want to access your computer remotely, okay, in the internet, then you can implement this application of telnet. Okay, you can install this telnet and you can make or you can use your remote computer like your local computer. So there it is going to create the interface in your computer and that is going to look like exactly like your remote computer. Another function is file transfer, access and management. So if you want to transfer the file, if you want to access a file which is present in some another location, then you will be using the function of application layer. Next is mail services, like as I said, to create a mail and to send it. And next is database services. Okay, if I want to store the large number of data in some location, then I may use the directory service of the application layer. So this is the summary of various layers. So what we are doing is, first of all, for a user to use the network, it needs to have the interface. Okay, that will be provided by the application layer, and the message that will be created in the application layer will be translated, that is to convert it into the form of sequence of bits. It can be encrypted or compressed by the presentation layer. Once it is done, it will be going to the session layer, which is if we want, then we can create the dialogue or the session between sender and the receiver. Then it will go to the transport layer, which is going to make sure that the message from sender process is delivered to the receiver process, that is process to process delivery. And to do this process to process delivery, the message will have to go to network layer, which is going to make sure that the sender and the receiver computer is uniquely identified. Okay, and that is source to destination delivery can be performed, and between source and actual destination you are going to have many hops or many node. So between every two node, how the communication can take place, that will be implemented by data link layer. And finally it is the physical layer, which is going to make sure that the sequence of bit is converted into the form of signals and which can be transmitted through the transmission media. So this was about the OSI reference model. This is only a reference model which has defined all types of function which we can use in network, in computer network. And in next video we are going to see TCP IP protocol suite, okay, which is currently being used in internet. Okay.